All right, part number 2. So we were just talking about nitrogen. Still got it up here. Oh, look at that. There goes my lights. All right. So nitrogen had 5. So he's going to bring in 3 electrons, makes him have a -3 because he's got 3 extra negative electrons in there. All right, now we'll move on to sulfur. I think is my next one. Oh, no, sorry, oxygen. Oxygen's got 6 in the outermost ring because he's got a 2 and a 4. So 6, he's going to bring in 2 extra. Bringing in 2 extra makes it so he's got his 8. That gives him a -2 charge. I know right now you're going, oh my gosh, Mr. Baby, going so fast. Trust me, in a minute, this is going to get really, really easy. All right. Then we go to the next one, which is fluorine. And fluorine has 7. Well, he's almost there. He just needs 1. So he's going to pull in 1 electron, but it gets him up to 8, ends up with a -1 charge. Then we still got 1 left, which was neon. And neon, he pulls in, he has 8 in that outermost ring. And because he's got 8, he's happy. So he's not going to lose. He's not going to gain. He's just happy. So he ends up with a 0 charge. Okay? And with a 0 charge, he doesn't like to, ultimately, we're going to find out, he doesn't like to bond with anybody else. Right? He just keeps to himself and just hangs out in the world and doesn't bond with anything because he doesn't end up with that positive or negative charge. He's already happy with having his 8 electrons in his outermost ring. All right, so what we ended up with then, let me get my periodic table. We ended up with, change hands, lithium right here had a +1, right? Because he had 1 electron in the outermost ring. Now the interesting piece is every single electron in this, or atom, in this first row right here has 1 electron in their outermost ring. Now I could assign to you, do every single one of these right here, and you'd find out they all have 1 in their outermost ring. What it is that goes here, 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 here is that 1 electron, right? Oh my goodness, you'd be busy making these all day. But they all have 1, so guess what? These guys all right here have a +1 charge. These guys in this next row right here, they all had 2 electrons in their outermost ring, just like beryllium at the top. So what we end up with is these guys all have a +2 charge. We're going to skip over the middle for right now, or come back to them. These guys, boron had 3 electrons in the outermost ring. All the rest of these, same idea. So they all have a +3 charge. Carbon had 4, so he had a +or-4. So all the ones that are in this group have a +or-4. Nitrogen had 5, so he ended up with gaining 3 electrons, so he had a -3. So all these in this row have a -3 charge. Oxygen had 6, he gained 2, he ended up with a -2 charge, and everything in this row has a -2 charge. Fluorine, he had 7, gained 1. All of these guys right here gain 1 electron, end up with a -1 charge. And everything that's in the end here is just like neon, where they are all happy and they have a 0 charge. So if I were you, on the periodic table that you downloaded a while back, I would put on here that this is +1, +2, this is +3, ±4, -3, -2, -1, 0. Because that's going to be something that you are going to reference from now until the end of this course. Okay? This is not something we're just going to learn now and that's the end of it. No, this is something we're going to use forever. Right? So +1, +2, +3, ±4, -3, -2, -1, 0. Now, what about all these guys in the middle? Well, what they are, currently the way in which I like to describe them, they are all +2. So you have to go +1, +2, +2, and then +3, +4, -3, -2, -1, 0. So everything in the middle, including the ones down at the bottom, are +2, with an exception. All right? And that's in your notes. And that is these guys in the middle, sometimes because they transition, they like to change, what they'll do is they won't be a +2. And the way in which we know that they're going to be not a +2 is what they do is they'll put the name and they'll go silver, which happens to be an element in the transition elements, and he should be a +2, but what we'll do is we'll put a Roman numeral 1 after him. And by having that Roman numeral 1, says that he's actually Ag with a +1, make that look like a 1, Jerry, +1 charge, right, instead of being a +2 charge. And you might go, why do they use Roman numerals? Why don't they just use the number 1? That'd be so much easier. Well, there's issues about this later when we get into writing formulas as to why we have to use Roman numerals, because we use regular numbers, then it can be confused for the numbers that we put inside of compounds. So the Roman numerals that you're going to need to know, you're going to need to know Roman numeral 1, Roman numeral 2, Roman numeral 3, right? You have to Roman numeral 4, Roman numeral 5, and Roman numeral 6. That's about it that you'll ever see, right? Now remember, 5 is a V, and really what ends up happening to get a 4 is you get 1 in front of the V, so it's really like 5 minus 1, that makes 4. And then you got 6 is the V, which is 5, and then the 1 comes after it, so it's like 5 plus 1, which makes 6. Right? So you need to know these 6 Roman numerals in order to be able to catch these exceptions. Right? All right, we're almost done with these notes. All right, naming these things. If the ion is a positive ion, so that means if it happens to be over here on this side, because remember, plus 1, plus 2, plus 2, plus 3, and it's plus 4, right, if it stayed as positive. When we name any one of these as an ion, what we do is we name it with just the element's name, right? Nothing really hard. So like this guy here, sodium, if he was a sodium with a positive 1 charge, then we would name him as a sodium ion. Pretty simple, nothing too complicated. These guys are all, we just utilize their name. Now we go to the negative ones. Negative ones, which happen over here. So we go -3, -2, -1, right? Even these ones, these could be -4. Those ones, what we do is we take the root part of the word. So I'm going to go with oxygen, and we go ox. And instead of ending in N, we end it in ide. So it becomes oxide. Nitrogen becomes nitride instead of nitrogen. Fluorine ends up becoming fluoride. Fluoride, oh, I've heard of that before. That's in my toothpaste. Yep. So we know that the fluorine that happens to be inside of your toothpaste is actually a negative ion of fluorine. It's not a positive one. If it was positive, it would be fluorine. But it's fluoride, so it's a negative ion. Right? So when they're positive, it's the atom's name. If it's negative, then we end it in ide. Okay. Now there is also, hold on, I think it's right here. Oh no. There is also a chart, which I call the, it's the polyatomic ion. I call it page 147 because out of my chemistry book, that's what it is. It is listed on the Canvas page. What those ones are is those ones are polyatomic. And what it means by polyatomic is they actually have more than one. Instead of just being the element silver or the element nitrogen, they have things like it's NO3. And that happens to be a -1. So it's made up of more than one element. That's why poly meaning many, atomic, atoms, many atoms. Right? So this guy is polyatomic. His name, how do you figure these things out? You're always going to go to that chart. Always go to it. You do not have to memorize that chart. You can use it anytime you want. Just like you can use the periodic table anytime you want. So that chart, what I would probably do if you're at home, I would print it off and then put it inside of my notebook somewhere, right with your printed off periodic table. Staple the two of them together, keep them together because you're going to reference them all the time. This guy's name is actually nitrate, ends in an ATE. There's also another one that's on that list, which is NO2. That one's also a -1. Notice the difference. This one had NO3. This one's NO2. They're both on that list. Again, you don't have to memorize them. You just have to be able to recognize that they are polyatomic, have more than one atom. Well, this guy up here, nitrate. This guy down here, nitrite. So this one ends in 8. This one ends in ite. If you look at that chart, you're going to find most all of the things that are on there end in either 8 or ite. And if they end in 8 or ite, then they come from that chart. There's only 3 exceptions to that, and that's hydroxide, cyanide, and ammonium. Those are the 3 that don't end in 8 or ite, and unfortunately you will have to memorize that those are on that chart. You don't have to memorize them, you just have to know that, oh, if I see hydroxide, cyanide, or ammonium, I got to go look at that chart. I'm not going to find it on the periodic table. And even though the first 2 ended in ide, so it seems like, well, they should be over here in the ide part. They're not. They're on the page 147 chart, the polyatomic ion chart. Okay. All right, I believe, I'm going to double check, but I think that's the end of the notes on this one. Yes, it is. So with that, we will see you next time. Have a great day.